This video builds on the first video published on Optimo for the SCH example. In that video, the example was built up from scratch and all of the nodes were explained. Here, only the overall operation of the example will be covered. This video assumes basic knowledge of how Optimo operates. To open the example, you must first open Revit 2015. With that open, navigate to the Extras folder in the Dynamo Packages folder. This folder contains the necessary Revit and Dynamo files. Open the Optimization Example 3 B-Box Autodesk Revit family file. Once that is open, go to the Add-ins tab in Revit and click on Dynamo 0.7. Then, open the Optimization Example 03 B-Box Dynamo file. The purpose of this example is to rotate an object and find its optimal orientation, which minimizes its bounding box volume. The object will be rotated based on the x, y, and z rotation values given by the population variables. Once it is rotated, the volume of its bounding box will be calculated. The bounding box will always be a rectangular prism with no rotation. As you can see, the graph looks almost identical to the SCH example graph. The only differences are the fitness function, the user inputs, and the visualization code. The population size and number of objectives work in the same way as in the previous example, only this example is single objective optimization. The upper and lower limits set the range of the rotation on the x, y, and z axes in degrees. Note that this time there are 3 indices in each list. This is because the population will consist of 3 variables which will be used for the x, y, and z rotation of the Revit model. The input to the fitness function is a geometric element. This must be set to the object that was opened earlier in Revit. To select the object, click on Change in the Select Model Element node, navigate back to the Revit window, and click on the object. Once that is done, the Dynamo graph is ready to run. The fitness function takes as inputs the Revit model and the 3 values for the x, y, and z rotations for the model. The node finds the center point of the model for a point of origin for the rotation. Then, it rotates the model and finds the resulting bounding box. The output is the volume of this new bounding box. After running the algorithm, the result shows up in Dynamo. The original object is on the right, and the newly rotated object is on the left. The left-hand model shows the optimal rotation for the minimum bounding box. The bottom of the graph is for visualization of the solution. These nodes plot both the original model and the rotated model in Dynamo, and calculate the bounding box volume for both models so that they can be compared side by side.